Hi, my name is George Garcia, and welcome to the fourth video on our Design Rules and Preferences series. In this video, I'm going to show you some practical examples of how you can set up rules so that way you get an idea of how you can leverage this in your own designs. Before getting started, I do want to highlight something, and this is especially important if you're coming from Eagle into Fusion. Let's go to the Design Rules editor. And if you import an existing Eagle design that uses net classes, you're going to find that you may already have some rules defined. Okay, and when that happens, it's because of your net classes. So if we go over here, you'll see in net classes diff pairs. Now I've created some additional rules in this design, but whenever you see that, if you see something coming in and you haven't defined any custom rules already, well, the reason for that is that if you had net classes, the net class rules are now defined here in custom. And you can see that also here in copper clearance. So you can see here, this is a self-clearance class. Okay? So keep that in mind when you're defining your net class clearances. If you had them previously defined in Eagle, they're going to come in to Fusion, but they're all going to be here under custom rules. So you'll see that with drills, with copper widths, and with clearances, because that's what net classes could do before. So again, we go to drills. You can see drill size in net classes, diff pairs, and then drill size for default. Anything that came from net classes will already be pre-populated. So with that said, let's go ahead and move on to our first example. For this example, we're going to address a common request, and that is the ability to define different rules relative to the specific layer. So I have some traces here. We're going to specifically be interested in $68. And as you notice, the trace has been routed all with the same width. Now, for impedance purposes, for signal integrity, I want to have the top layer have a different width than the inner layer, or the second layer in this case. So how can we do that with the new rules engine? Let's go ahead and click on the Design Rules editor. We're going to go to Custom Rules, and we're going to go to Copper Width. We're going to add a rule for copper width, and I'm going to say that this one needs to be 12 mils. And we'll see that the preferred gets filled in. Object, we're going to say, is in signal. This is a scope. In signal, and we're specifically interested in N68. So go all the way to here, N68, and $68, we select it. Now we're going to add another condition. The condition is that this signal has to be on layer top. Okay? Let me give this a name. I'm going to say top copper width and $68. You can be as descriptive as you want to be. Okay, and the more descriptive, the easier this will be. So we have it. We have our scope. Remember, a copper width is a unary type rule, so that means it's only affecting one type of object. It's not something that's between objects like the clearance rules are. So we have unary and we have binary rules. This is an example of a unary rule. So now I'm going to click OK. And when I do this, you're going to see that we have the warnings reported. We have the error. So now what I'm going to do is I'm going to rip this up and we're going to route. And you're going to see that the manual route acts on the rule as well. So let's go to Design. Click on Route. Make sure it's on the same layer because I don't want to undo the part we have on the bottom. Go to Manual. And now you'll see much thicker. So this type of scope in signal and on signal layers is going to be the key to defining layer-specific rules. This will allow you to define layer-specific clearances, layer-specific widths, and anything that you want to control in that manner. So keep those two key scopes in mind. In signal and on signal layers. See you for the next example. In this example, I want to illustrate the use of a component scope. So how does this work? So let's say I have these diodes, and I want to make sure that any traces that are connected to these diodes and part of this group will have the same width. So the first thing we have to do is create our persistent group. So I want to make sure I get the air wires as well. So I'm going to hit Control, select. That way I include air wires. I'm now going to form my selection. Now I'm going to right click, and I'm going to say New Group. I'm just going to call it Diodes. Now with this group, what we can do is we can go into the Rules Editor, go into Custom Rules, we go into Copper Width, and I'm going to create a new rule now. I'm going to call this Diodes Group Width. And I'm going to make it again something big to make it very discernible. And now we go here again, our scope. We're going to go in named group diodes. Okay, this is our one group here. And we're going to click OK. And once we do this, you're going to see that all of the traces that are in that group are giving an error because they're all thinner. And then again, if we use the route command, then now we get the thicker trace. And these are all correct. Okay? So using the component groups, you now have another way to scope rules. So you could have multiple groups in a design and you can define individual widths for them. So for example, if you're routing a high density BGA, you may have a rule based on a group including the BGA and maybe any support circuitry that has very thin widths. Or you can also do isolations between groups, for example. But it's all possible because we have this in named group scope. So this is something that net classes couldn't do, that any of our other scopes couldn't do, but it's something that you can creatively leverage to granularly control your design. So keep that in mind. This is our example for component group. See you in the next one. For our next example, I want to show you a really powerful rule type. This is something that has never been possible, and that's the ability to scope using components. So let me show you how this is going to work. We're going to go Rules. We're going to go to our Design Rules Editor. And I'm going to go to Custom Rules. And I'm going to go to Board Outline Clearance. Okay? So imagine a scenario where you need components to be away from the edge of the board or from a hole or any other type of cutout. So I'm going to click Add Rule. And I'm going to say C35 clearance. Okay? And I'm going to put something really big just so that it guarantees a failure. Okay, as we spoke about before, minimum and preferred. There's error checking here. So what are we going to do? We're going to go Object. The scope is in component. Okay. We're going to find our component. And the one I'm interested in is C35. We select C35. And I'm going to say that it is a pad, an SMD. So what does this initial condition do? It's basically looking at the copper inside the component, and we're using that to create the rule. And I misspelled clearance. Let's fix that. And we're using that to create the rule. So what is object 2? Well, you notice object 2 is set to all. Now, normally, all is something to be avoided because it's just going to grab too many things. But because this specific rule type is checking between an object and then it's checking between any copper object and objects on the board outline layer or any hole, then all is okay. So we're going to leave that as all. And what this rule is effectively doing is checking the clearance between C35 and the board outline. So we're going to say OK. And you're going to see that there we have our clearance violation. So this in-component scope is very powerful because in this case we use the SMD pads of the component. But in-component contains everything that is in the component. So you can use the silkscreen lines. You can do clearances between components even. So keep in mind that scope. It is extremely powerful. So for this example, I want to define an intercomponent clearance. So we're going to, in this case, look for a clearance between this capacitor C234 and this IC U206. And the way we're going to do it is we're going to go again to our rules editor. We go to custom rules. Now you'll notice there's no rule for intercomponent clearance or component to component clearance. But what we can do is we can use copper clearances and scopes to achieve that rule. So I'm going to select copper clearance. I'm going to add a new rule. I'm going to say different signals in this case because the components will likely connect to different things. Although it doesn't matter because of the way we're going to scope it. I'm going to call this intercomponent clearance. Again, the more descriptive, the better. I'm going to use something big to make sure that we see the error occur. Okay. And what we're going to do is we're going to go use our in-component scope, C234, and we're going to use the copper objects within the component to define the clearance. So we have this isPad or SMD. When in doubt, use isPad or SMD. In this case, I know this is all surface mount, so I could just use isSMD. But for most cases, if you're unsure or you don't know what version of a component you may use, isPad or SMD will cover both. So we do that. Now we go again. Object 2 is in component as well. Now we find U206. And again, isPad or SMD. We say OK. You'll see there's our violation. So where can this type of rule be useful? Imagine you have components that have temperature sensitivity in a high-power design. It may be useful to really define how close these sensitive components can get to components that emit a lot of heat due to the power that they're processing. So this is a way that you can exercise more control over your design without even having to think about it. You can define these rules. As you push the component closer to each other, you see the error, and then you can make the arrangements that are necessary. Move the component, adjust. But you know at the onset that there is a violation and that a component is too close before you make a prototype run, and then things start to heat up and the board begins to fail. So thank you for watching. See you in our next example. For our final example, I want to highlight something that has in the past been a rule that's actually been quite limiting, but now with the new design rules editor becomes very flexible. So what am I talking about? Let's go to the design rules editor. If you're coming from the Eagle background, you know that in the past you only had one drill clearance value. This was it. This was for everything, for vias, for pads, for drills of any sort. You know, this was the one setting you could control. But now let's go into the custom rules, and I'm going to show you what you can do with this now. So if we go to custom rules drill clearance, we're going to add a rule, and let's do something basic. Let's say, for example, you have a board, you have holes that are for mounting, and you want to make sure that component pads don't get too close to these holes, because if something misses, the pad may break, the hole itself may go into the pad. You know, if tolerances are poor, those things can happen. So let's say you want to establish a rule based on the manufacturer that will make sure that you never have pads, component pads, too close to drills. So I'm going to go ahead and call this hole pad clearance. Again, as been the pattern, just to highlight that it detects the issue. I've been using large values, so I'm going to do the same thing here, 100 mils. Real life, you would use whatever the manufacturer spec is. So object. Notice that we can pick is a pad, is a via. We can even define rules based if they're through hole, vias, micro vias, blind or buried. So there's a lot more control over drill clearances. It's not that one parameter that we used to have. Rather now, you can really drill down and be very specific about these clearances. So I'm going to pick very simply is a pad. That's what I'm worried about. And now object 2, let's look. We want a hole, but we don't see a hole in the list. If that ever happens, check object type. There's hole. So using this, we've defined a rule that checks the clearance between holes and anything that is a pad, and is going to flag a violation if it exceeds 100 mils. So I'm going to say OK. And there we are. Okay. So through these examples, we've shown that the new design preferences and design rule editors are much more flexible than the DRC of the past. Using powerful scopes, you can define very specific rules. As you've seen, priority is important. The more specific a rule, the higher its priority should be. And if no custom rule is defined, then the general rules are used. Thank you very much for watching this video and this series so far. As time goes on, we hope to extend the series as new rules and new capabilities are added. Thank you very much for watching. Have a great day.